Hello everyone and welcome to the online class of class 10th physics. Today our topic is Ohm's law. Let us discuss something about Ohm's law. In 1827, a German physicist, George Simon Ohm, 1787-1854, found out the relationship between the current I flowing in a metallic wire and the potential across its terminals. So actually Ohm's law is a law found out by Mr. German physicist George Simon Ohm, and this law actually states the relationship between the current flowing through a conductor and the potential across its terminal. So let us see what he stated in the Ohm's law. He stated that the electric current I flowing through a metallic wire is directly proportional to the potential difference V across its ends, provided its temperature remains constant. So this statement is Ohm's law. So what actually Ohm's law stated, that the electric current flowing through any metallic wire is directly proportional to the potential difference V across its ends, provided its temperature remains constant. So in another way also we can say it like Ohm's law states that the electric current flowing through a metallic wire is directly proportional to the potential difference across its ends, provided its temperature remains constant. So let us see its mathematical statement. In other words, V is directly proportional to I. We have written it. V by I is equal to constant. Now this thing we have to keep in our mind. V by I is equal to constant. Actually Mr. Ohm had performed a lots of experiment in which he had verified this law. Like he had arranged the experiments, the circuit, and in that at different values of voltage he had obtained different values of current, and at each and every stages he start taking out the ratio of these two, and he had seen something very strange, that all the time this ratio is coming a constant value. So from that only he had came to the conclusion of Ohm's law, and he stated it. That only we are saying right now here. So V by I is equals to constant. Now here this constant is R. Now what is R? R is the resistance of the conductor. This is the property of any conductor, to resist the flow of charges or electron through it. We'll see it more now. Okay, again V is equal to IR, I is equal to V by R. These all are the relations of Ohm's law which is helpful in solving the numericals. Okay, the graph which Mr. Ohm had observed in his experiment is the graph between current and potential difference, and it is a straight line passing through the origin. Okay, something I have written here over about the resistance, where R is a constant for given metallic wire at a given temperature and is called its resistance. It is the property of the conductor to resist the flow of charge through it. What is the resistance? Actually, it opposes the flow of charges through it. So this is the property of each and every conductor. It means even the superconductors also does possess this characteristics of resisting the flow of charges, flow of electric current through it. Okay, now some more thing I have written about the resistance. Its unit is ohm. There I had written 1 ohm. V by I had taken the formula V by I, where 1 volt by 1 ampere, and it is equal to 1 ohm. If the potential difference across the ends of the conductor is 1 volt and the current through it is 1 ampere, then the resistance R of the conductor is 1 ohm. So it is very easy to understand about the 1 ohm. 1 volt by 1 ampere gives you 1 ohm. Okay, now let us see some more things about. From the equations we can see current through the resistors is inversely proportional to its Resistance, very good. Square statement, yeah. You can see that there is an inverse relation between current and resistance. It means if we increase the current, resistance will decrease. If we decrease the current, resistance will decrease. Or if we increase the resistance, current will decrease. If we decrease the resistance, current will increase, and vice versa. This is very simple thing. We all must know these things already. To change the current in the circuit without disturbing the source voltage, we can change the resistance to do it. Okay, we don't want to disturb the voltage and want to change the current, so we can change the resistance of the conductor. It means we can replace the conductors and we can get some different values of currents. Okay, we have to study about the dependence of the resistance on the factors on which the resistance depends of the conductor. That we'll see in the next class. In this class we are discussing only about Ohm's law. So if increase the resistance, then current will decrease and vice versa. Okay. Now one more thing I had written over here. Let us discuss. This is the last thing. In an electric circuit, a device called Rheostat variable resistance is often used to change the resistance of the circuit. Okay, if you want to change the resistance of the circuit, then we are going to use one variable resistance, that is called the rheostat, in the circuit. So I think this much is enough for today, and in the next class we'll discuss more about the resistance and its dependence on different factors. Okay. And one more last thing about the Ohm's law, I would like to state that one condition we have to keep in our mind here is that at a constant temperature or at a given temperature, voltage is or current flowing through the conductor is directly proportional to voltage at a constant temperature. Okay, thank you everyone.